A lot of people call it digital mesh networking, but mesh is a bit of a misnomer. We're actually building the ham radio internet. I won't go into my name and affiliations because Michael's done more of that than I could stand. All right, so the digital mesh networking is kind of like packet networking, only way faster. Back in the early 80s, we started with it, and it was 1200 baud. Wasn't that fast then, and it looks even worse now, because that works out to be 0.0012 megabits per second. We can pass traffic with it, but with the overhead of IP networking, you really couldn't do much networking with it at all. And I spin forward 30 years, and now we've got digital networking. 100 plus megabits per second. Sounds pretty impressive, but remember, that's the modulation rate, not the true throughput. If you guys have any experience with packet, you know the more hops you go through, and some of those hops happen to be poorer links, you get way less than the maximum data rate. That's also true with digital networking, but because you're starting so much faster and the latency is so low, you can move a lot of data in pretty good order. So the equipment is just commercially available wireless access points. There's no hacking required. Back in the early days of mesh networking, all we had was the Linksys WRT54G. And to get it outdoors, on a pole, weatherproof, with antennas and power, required a lot of work. Fortunately, we progressed and we don't need that anymore. So you take this commercial wireless access point, and just like upgrading your router at home, you upload firmware, but in this case, it's customized for ham radio. Back in the 90s, when Linux was the really hot thing, Linksys said, you know, we can base all of our equipment firmware on that. And they did so, and they ported it. And the open source community said, we can do better than that. And they took the source code, which is completely legal with Linux, and one group spun off OpenWRT and another group spun off DDWRT, which are still in existence to this day. And by the way, if you have a router at home, go look on OpenWRT and DDWRT and see if they have software for your brand and model of router, because the factory firmware is notoriously insecure. DDWRT and OpenWRT are secure. They're constantly being updated for security and features and bugs. And that's all I'll say about that. So anyway, the ham radio community took OpenWRT and created in the beginning a broadband hamnet. About 4 years ago, the AREDN group was spun off of that to focus on other than Linksys. So you put these nodes with this firmware on the air, and if they hear each other, they discover each other, and they discover routes, which is the main point of the firmware. You don't require a lot of network knowledge to get them up on the air. So the bands. 900 megahertz, and I'm not going to say much about it because while it does do better through trees and rugged terrain and that, we only have 5 megahertz of bandwidth there, which isn't all that much. And it's an awfully noisy band. We share it with all other sorts of things, including smart meters. So some people use it here in the suburban areas, urban areas, not so much. Then we have the original 2.4 gigahertz band where the Linksys got started. When they moved to Ubiquiti, we gained the 3 gigahertz and the 5 gigahertz bands. So we've got quite a mixture there. And I'll talk about these more later in the presentation. So, what's out there? Most people use Ubiquiti equipment, the outside access points that I mentioned. They're available for those 4 amateur bands. Because they're designed for outdoor use, they're weatherproof. Just put them up and don't worry about them. The old Linksys WRT 54Gs put out about 60 milliwatts. If you're good for hacking on them, you maybe get 100 milliwatts out of them. But by the time you go up through the coax to the antenna, there's not much power. Ubiquitis put out around 10 dB more, 600 milliwatts. So you got a significant gain there. Additionally, the Linksys hardware is 15 or pushing maybe 20 years old now, and the newer hardware has faster CPUs, more RAM, more ROM, much better receivers, and that's why we've moved on from the Linksys. The Ubiquitis use two software-defined transceivers, not one, but two. Those two allow them to run MIMO, multiple input, multiple output. Those transceivers are amazing. I can't tell you how much I admire the technology that goes into them, the modulations they can do on the fly from packet to packet. Big advance over what we were using in the past. Most of the models, many of the models have built-in gain antennas. Once you buy the unit for your house, you're good to go. And I said they run MIMO, which allows you to run 802.11n. If you're interested, Wikipedia has a good overview of 802.11n. I recommend you skim it. Hopefully it won't make your head hurt like it did mine, but it'll give you a feeling for what all that little inexpensive piece of hardware is doing. It's pretty amazing. And they do run power over Ethernet. They run the power and the data up through the same Ethernet cable, which means only one cable going up the mast, which is a good thing. One cable per node. So these access points are kind of like your handy-talkie. They're low power, and they're even more limited to line of sight than a handy-talkie would be, being the higher frequencies. What that means is you usually communicate through Hilltop sites, not point-to-point. And it's very rare for somebody to go handy-talkie to handy-talkie. You're always using a repeater, and it's pretty much the same way with mesh. So what's out there from Ubiquiti? Most people use the nanostations, M2 or M5. We're encouraging people, if there's no activity in their area, to go directly to 5 gigahertz. The equipment's about the same cost. You get double the bandwidth, and the band is a little quieter. So we find them they work substantially better. Other equipment, you also have the TP-Link CBE 210 for 2 gigahertz and the 510 for 5 gigahertz. Any TP-Link you buy now, you'll have to run the nightly build firmware on it because they changed the hardware inside. But the nightly builds are freely available and recommended. I ran a couple of these early on. They ran fine. The early TP-Links were about the same cost as Ubiquiti, but when I checked the cost on Amazon, they're about half the cost. Depending on our situation, you might end up paying more for the coax to hook this thing up, Ethernet cable, than to purchase the node. These are a good alternative. If you really need to reach out and touch that remote Hilltop site, the PowerBeams are very cost effective. They put a stomp crunch signal out. Because of the high gain, they have narrow beam width. So you'll only be talking to the one person, one node you want to talk to. But if, like around here, it's a Hilltop node that's connected to your county backbone, you're good to go. And by the way, for those who aren't familiar with mesh, everything's in that little cylinder in the middle. The Ethernet interface, the computer, the RAM, the 2 radios, and there's some sort of focusing antenna in there to point back at the parabolic dish. It's quite a buy for 80 bucks. So let's look at some home installations. This is the QTH of KM6FQ. He's about 3.5 miles to the east of me. And back when we had to operate in the Part 15 band, this is what we had to do to talk to each other. You can see his Nanostation M2 at the top of a 50-foot self-erected tower. On the other end, I had an Omni antenna at 50 feet on my tower, and there was nothing in between, and we had very poor link qualities between us. moving down into the Part 97 part of the bands fixed all that, and I'll talk more about that. So nowadays, if you've got line of sight, you can do something like N6OOR did here. You can see his nanostation about 6 or 8 feet above his roof. So that's not hard to install at all. Or if you're like K1GGS, you just hang them off your second-story gutters there, off the eaves. Now you'll notice here, Rusty has 2 nodes up there. One's an M2 and one's an M5. And why would you want to do that? It turns out that the Hilltop that he's talking to has access points for both of those bands. And he's put them both up. What will happen is his station will pick the best route, the best quality link, and use that. If that link happens to go down, it will automatically switch over to the secondary one. Now, this is what we're doing with all our EOCs and hospitals in this area. Anytime we equip them with mesh, we put 2 nodes up. In some cases, they're pointing at different hilltops, but you still have redundant connections. You can go portable too. This is KM6FQ's portable installation at one of the aid stations at a recent Red Cross charity bike run. You can see the camera mounted on top of his car. It's pointing back at the aid station where the bikers were pulling in for water and whatever. We streamed video from that camera out onto the mesh network. From there, I streamed it out to YouTube, and the Red Cross chapter was able to view that and a couple of other aid stations via mesh. It worked pretty well. We learned a lot from it. So, just like you wouldn't put a cheap Chinese handy-talkie up on a repeater site for use as a repeater, you probably wouldn't want to use one of the nanostations on a hilltop due to RF density and stuff like that. So here's a sampling of what you might put up on a hilltop. These are Ubiquiti rockets, M2 and M5 for 2 gigahertz and 5 gigahertz. The electronics inside is pretty much the same as the nanostation, but you'll notice no internal antenna. Instead, you've got 2 SMA connectors for both vertical and horizontal polarization. This lets you choose the antenna of your choice depending on your situation. So looking on the back of this sector antenna, you can see the rocket mounted on the back, and you can't really see them, but there are 2 little coax jumpers going inside. They're called sector antennas because you can buy them for 45, 60, 90, 120, or 180 degrees coverage. And by the way, that's both vertically polarized and horizontally polarized. It's a MIMO antenna. You'll see a lot of these used. You can also buy Omnis. They are gain antennas. There's a gain vertically polarized antenna inside each one of these, and a gain horizontally polarized Omni antenna inside each one of these. That's why they're kind of pricey. You don't see these used much in mountaintops because frequently the coverage you need is mostly in one direction. And if you need 2 different directions, most people put 2 sectors and 2 rockets up there. It builds up the hardware very quickly, and I'll show you that in a minute. So, wanted to talk about MikroTik. That's a base 5 mounted on that post going to a sector antenna. They're currently in early testing. The reason they're looking at using MikroTik is because the newest generation of Ubiquiti equipment, the all 802.11 AC stuff, is not open source friendly. We won't be utilizing it for various reasons in ham radio mesh networking. MikroTik does supply models where the code has been ported to. It's functional. It has the same chipset inside it. So when Joe AE6XE ported the code quick and dirty last year, it came right up and ran. They use the same chipset. They'll go into beta tests later this year, and if you're adventuresome, they would be more than happy to have you buy one of these and put it up. It does run, it's fully functional. what they're missing is a few bits and pieces around administration, getting the LEDs to light properly and stuff like that. But they pass data like crazy. They're a little bit cheaper than Ubiquiti, maybe 2/3 the cost of a sector antenna and a rocket. So once we get these rolled out, I expect them to be very popular, and there are a lot of models. Speaking of which, remember I mentioned that a Linksys was 60 milliwatts output? That radio you're looking at there is 1,000 milliwatts output, 30 dBm. And I have seen pictures of it mounted on the back of a MikroTik 30 dBi gain dish antenna. Folks, that's 1 kilowatt ERP. You do not want to stand in front of that. You can really reach out a long ways and touch someone. We're looking forward to deploying those. So let's look at sites starting small, medium, and large. Some typical installations, and my apologies, these are all kind of Southern California focused because that's where I live and that's where I had photos. But I'm sure your mesh groups have similar stuff, although you probably have more pine trees than we do. This site is in North Orange County, looking south into the county. It's all solar cell and battery operated. It's about a quarter mile from the nearest dirt road. There are 3 sector antennas here now. This one showed 2. This is an older picture. 2 cameras and I don't know what all else. So this is about as small as you can get. Here's a medium-sized site. This is all ham radio. This is an older picture. Since then, there are a few more node antennas up there. I think are on that pole on the front left corner. This is solar augmented by AC, or maybe it's AC augmented by solar. I don't know. This is the middle of Ventura County. This is, I don't know, medium, maybe large. This is the site on the eastern end of our valley. Looks very busy. On the top, you can see an Omni antenna for a 2-meter repeater. The big dish on the lower right is a 5 gigahertz parabolic dish that connects us to the county backbone. Above it is a 2 gigahertz rocket and sector antenna, which is our 2 gigahertz access point for the eastern end of our valley. It's not used much anymore because everybody on the eastern end of our valley has moved over to 5 gigahertz. And they're using, if you look, bolted on the leg of the tower is a Nanostation M5, like I told you not to do. Well, mostly. We're down lower than all of the RF emitters you can see in the towers on the upper right. Additionally, you can't see it, but that Nanostation is encased in a metal can that covers everything except the front side, provides very good shielding. The other reason that I use the Nanostation for this is it only has a 45-degree beam width. Normally that would be a disadvantage, but our end of the valley tapers and this coverage fits it very nicely. Lower left, the sector antenna is for a Part 15 access point for some commercial customers. You can see the camera covering the valley, which is, by the way, scheduled for an upgrade to a nice PTZ camera this fall. On the upper left is a 3 gigahertz sector. I use that for connecting the 3 Hilltop sites that cover all of our valley. It's sort of a local backbone. This site's only been in existence for 3.5 years, so you can see it's grown quite a bit since we poured the concrete. And you can't see it, but that piece of black pipe on the left, lower left, goes underground to a small container off picture to the left where the UHF and VHF repeaters are and a little bit of ancillary gear. So this is a serious commercial site. This is Pleasants Peak in North Orange County. Joe AE6XE, one of the developers, lives down there, and he had access to this site. And all of this has been deployed in the last 3 years. This is one of the main distribution points for Orange County. And you can see that's a serious amount of equipment. That's not like buying a handy-talkie. You need a serious group supporting something like this, like you would need a group supporting a large repeater site with multiple repeaters and links and stuff like that. So, what else do you need to get started at home? You need some Ethernet cable. If you've ever left plain old vanilla network cable outdoors in the sun for a year, you know why. It crumbles due to ultraviolet. It's not ultraviolet resistant. So what you need is outdoor, or sometimes they call it direct burial network cable. It's a little more expensive. Ubiquiti recommends shielded cable, and you'd certainly want to do that on a repeater site or any other mountaintop site, or anywhere where you get lots of lightning. Out here in Southern California, our weather's pretty benign. I don't use shielded cable. I've never had an issue. Your mileage may vary. It's a pain to hook the connectors on the shielded cable, so I buy pre-terminated links, but if you're handy with crimpers and RJ45 plugs and connectors, you can just buy a roll of cable. The mesh network is a standalone network in your shack. There's no connection to your home network, so you need a dedicated computer for it. That little asterisk there means there is a way to do it. It requires another inexpensive piece of equipment, a network switch that's VLAN aware. They're not that expensive, but there's instructions on how to set it up on the AREDN website. Excuse me. And if you run more than one node, you will need a network switch. Doesn't have to be real expensive, and if you buy the little VLAN aware one, so much the better. Killing two birds with one stone. You really, really need a clear line of sight because microwaves don't like trees, not even one tree. I have my 3 sites linked by 3 gigahertz, and the 2 that are closest to each other can't talk to each other because there's 3 eucalyptus trees about 200 feet away from one of the sites. And even in the winter with no vegetation, we can't make the haul. So plan on line of sight. So we put all these nodes on hilltops, and they found each other, and you've got a nice backbone network, but it's just a network. It doesn't do anything. It's really all about the services. What are services? They're things you can actually use, like keyboard-to-keyboard chat, voice chat, video, document editing and management, various kinds of drop boxes, web servers or pages, whatever you think you want to put up. Store and forward, that's another name for email. Repeater linking, we're starting to use mesh networking for repeater linking, not just DMR, but standard vanilla repeaters. And anything else you can think of, but you do have to obey the Part 97 regulations. So let's talk about some of these. IRC is kind of like the granddaddy of keyboard chat, internet relay chat. The nice thing about it, you can have a dedicated channel or create a channel on the fly. And you can link servers together. Here we have one in Eastern Ventura County, Western Ventura County, and one in Santa Barbara County. They're all linked together, and when you log on to one, you see all of the people logged onto all of them, and your keyboard chats are distributed to all the linked servers. It is client-based, XChat, HexChat, there's a bunch of others. But there are web-based clients, and we do run a couple here, and they're advertised out on any kind of web server. So this is HexChat, and this is not a mesh chat, but I just threw this up here so you knew what it looks like. If you've ever used it before, it should be very familiar. We don't have that many people logged into ours, but the concept's the same. There's another piece of chat software called MeshChat. It was written by Trevor, K6 or K7 FPV, I think. He's now on the AREDN team. Originally written for nodes, but they discovered when they linked up 6 or 8 of them, it ran the node out of resources. So now it runs on a Raspberry Pi. It was an easy port since they're both Linux-based. If you want to try it, feel free to do it. A Raspberry Pi. Little asterisk there means that the latest version of Raspbian, the Raspberry Pi operating system, made a small change that broke MeshChat. It's easy to fix. The fix has been published. and it runs very well. You can create multiple channels like IRC. The nice thing about it is it automatically finds other mesh chat servers, and they sync between each other. It does have a web-based interface right off your same computer you're using for your mesh network. And it has a built-in Dropbox where you can drop files onto the Raspberry Pi and share them. This is what it looks like. This is just a sample that Trevor put up there. And that's what it looks like. In the upper right, it says Mesh Chat Users. If you have more than one node length, they'll all be listed there and the last time they were seen. We used this for a while, but we've settled on IRC. All of the applications I'm going to show here, and which is by no means all you can run on a mesh network. These are all things we've tried. We aren't necessarily running them all now, but we have tried them all. So phone calls, voice over IP. This picture was taken, I don't know, 3.5 years ago when we were prepping to start experimenting with VoIP. That's an old Cisco phone on the left, a VoIP phone. I think they're 25 or 30 bucks on eBay now. On the right is a Grandstream VoIP PBX. If you have somebody who's really, really sharp with Linux, they can run Asterisk or Free PBX or something on a Raspberry Pi. The guy who was implementing this was not into Linux then, and he chose a commercial installation. It's got some very nice web-based user interfaces. So this is what we chose to deploy. So you spin forward to today. I'm now using a Grandstream phone. Works very nicely. You can see that I missed one call, and I do have one call waiting on the PBX. It supports voicemail. And you'd be amazed at how often that red light is lit when I walk into the shack. We're going to be deploying VoIP phones to all the EOCs, all the hospitals, and they're up. There's a phone at H Repeater site where we have mesh. You don't have to dial somebody to use voice. You can use a voice chat server. We use TeamTalk. There are other examples, TeamServe, something like that. TeamTalk works well for us. It lets you do one-on-one voice chats, many-to-many chat rooms. You can set up as many channels for voice discussions, conversations, QSOs, as you want. And the cool thing is, it's not like an FM repeater. You don't have to wait your turn. You can spin off to another channel and have multiple simultaneous conversations. You can use a speaker, microphone, or headset. And I wanted to mention that if both ends have a headset and the audio levels are set properly and your links are good, the audio quality is just gorgeous. I would call it high fidelity, not 300 hertz to 3 kilohertz. This is not your father's FM repeater. It's just a pleasure to listen to. During the week, I leave push to talk on. I use the left Alt key. But during our Sunday night nets, I put the headset on and switch to Vox and lean back and put my feet on the desk and just chat when I want to. It's just a lot of fun. It also supports open mic, which is full-time audio end-to-end. And maybe if you had some sort of emergency going where two EOCs need to talk to each other frequently, you can set it up like this and have somebody run up to one of the computers and say, "Hey, Joe," and it comes out on the other end. In addition to voice chat, it supports video, file sharing, and desktop sharing all at the same time, all available to anybody. Here's a screenshot of one of our nets taken late in December last year. On the left, you can see the people who are logged in. There's 6 of us. The one in green is the person who's talking. After he stops talking, it turns to orange and then goes away. 4 of us at that time were running video also. I'm on the upper left, N6OOR is on the upper right, Cam6FQ lower left, and Rusty K1GGS on the right. Up at the top, you can see there's a chat tab, a video tab with 4 sessions. You can also see a desktop session. Joe, K6NE, who is logged in here into this chat session right now, hi Joe, had just finished sharing a slideshow of the remains of his repeater site after the Thomas fire overrun the north half of Ventura last fall, and there wasn't much left. But it brings to mind how useful this could be, sharing a desktop and showing things to people. By the way, the TeamTalk server runs on a Raspberry Pi very nicely, and with 4 video sessions and 6 people logged in, 1 talking, and 4 video streams, Raspberry Pi was under 5% CPU utilization, and I think the data stream in and out was, I don't know, a couple of megabits per second. Not bad at all. It's one of my favorite applications. Another thing we've got going is ADS-B. It's basically Waze for aircraft. It shows you their tracks. You need an ADS-B receiver, and we have 2 in the county on mountaintops hooked to our mesh networks. You can see aircraft track at any given time. We threw this one up during the Thomas fire. What you're seeing here are the tracks of 2 water bombers making passes over northern Santa Barbara County. Had we had mesh at a fire camp someplace in the area, they might have found it useful to watch. Another possibility. And of course, there's webcams. This is an old shot. Ben AI6YR in the foreground. It's part of the Canal Valley Amateur Radio Club, and they were setting up the Friday before Field Day in 2016, and he threw up a webcam. It's only 7 miles away from my QTH, but it's over 2 sets of hills. So we had to do about a 40-mile total path, and I grabbed this screenshot as they got set up. So any place you've got mesh connectivity, you can throw up a camera and show what's going on. And I'll talk about that some more. This application is called iSpy. It's an open source video viewer. Highly recommended. It's free. You can use this for your home security cams or whatever. You just have to have access to the cameras. This is on our mesh network. This was taken around Christmas last year. Not that a view of a driveway is interesting or anything, but I had thrown that camera up to be part of my home security system, and I put it on the mesh network for testing. It was the first full-time webcam we had on the network. Glenn's tower cam is on the upper left. I have no idea why he wants a picture of his tower, but whatever. Lower left is a camera on the western end of our valley, looking north. It's a fixed focus. Lower right is up on Chatsworth Peak, looking west-northwest into Ventura County. And if you look very closely, you can see the smoke from the Thomas fire. If we'd had a pan-tilt zoom, we could have zoomed in closer, but I've got another more impressive screenshot of that. A little background on this next slide. Whenever I come into the shack, I fire up iSpy on a second a monitor off to the right, just to make sure all the cameras are running. You really don't want to run it full time because you're just sucking up bandwidth unnecessarily. But I had it set up, and I was looking at this and a different camera, and I noticed a flicker of motion up close to one of the cameras, and I looked over there, it was gone. So I got set up to do a screenshot, and when it happened again, I stabbed the print screen screenshot key, and I got this. We got quite a laugh out of it. We still don't know whether that's a rodent, like a squirrel, or a raptor. We have a number of hawks around here, but that's a classic. This next one isn't quite so funny. I mentioned the Thomas fire. A little background. Ben AI6YR, who was in the earlier webcam shot of the Canal Valley Amateur Radio Club field day site, is also a tech specialist in the Santa Barbara section. He had emailed me in late September with an article, a link to an article on how to stream webcams to YouTube. He said, hey, see if you can figure this out. We might use it someday. I looked at the article and said, well, I don't know if I can do this, but it turned out not to be that hard, and I successfully set up one of our local webcams to stream to YouTube, and it did in fact work. So I filed that away for further future use. Well, spin forward, I don't know, 6 or 8 weeks. December 4th, 7:14 in the evening, the Thomas Fire broke out just north of Santa Paula in Ventura County. Ben pinged me right after that and said, "Hey, we have a camera on Sulphur Mountain. Do you think you can stream it?" Well, different camera, different site, different computer, but by about 8:20 in the evening, I had this streaming out to YouTube. And it was pretty impressive. The fire was getting closer and closer. We streamed for about an hour and 45 minutes until we lost Edison power to an intermediate site. The winds were howling, which is one of the reasons the fire took off so fast. After the site lost power, this fire you can see there proceeded from right to left and passed about 100 yards north of this tower. The light you can see in the center is lighting the site owner's driveway. It's gone, as are the gates. His house was untouched, fortunately. We lost many, many houses in Ventura on that fire. It was terrible. Interestingly enough, I got an email from a fire investigator from the Ventura County Fire Department, I don't know, a week after, and asked for the URL. He made the comment that it was the first video they had of the fire. And I heard later that they found it useful. So the lessons we've learned from this is, A, we need to harden the sites. We're working very diligently at getting at least battery backup power to all the mesh sites. B, hams frequently are on sites where there is no commercial or governmental presence. So a camera may have a unique view up there. So we're looking at pushing cameras to all of our mesh sites and pushing the mesh network to other sites that we can cover more users, obviously, but also have unique views of their area. We're also upgrading all of the older tube cameras to full-blown pan-tilt zoom cameras so we can turn around and look. So this got real serious real quickly. Oh, by the way, I want to mention one more thing. This site does in fact have solar and battery backup, but we lost battery power after about 12 hours because the smoke was so thick that the solar cells couldn't charge the batteries. Another lesson learned. I don't know what we're going to do about it, but something to be aware of. So, document sharing. If you've ever used Google Docs, you know that you can do, you may not know that you can do, you can share it with other people, but you may not know you can do concurrent editing. Multiple people can edit the same document at the same time if you wish. Etherpad will do the same thing. It's open source. Doesn't support spreadsheets, but it does support tables and text. And it's open source. I think I said that. And it runs nicely on a Raspberry Pi. You'll hear me say that a lot. Pretty much everything we've tested here runs nicely on a Raspberry Pi. NextCloud is a Dropbox-like thing. We've tested that, and it works fine. You can have password access to various files. Works very nicely. So here's a screenshot of a sample Etherpad. The text is color-coded depending on who's typed it. And here's a screenshot of somebody's NextCloud. You can add as many folders as you want and share them with others. A lot of possibilities there. So let's talk about email. Servers and clients, what can you say about email? It's Thunderbird. Also, RMS, Express, Outpost, and WinLink are used in ham radio. They use Packet for moving the data around. We had a couple of users of this software, I think RMS Express, who were forwarding data via Packet, and they switched over to Mesh, and their comment was, "Wow, does this move traffic fast?" Which is about what you'd expect. So lots of possibilities there. Back in the old days of dial-up, we had BBSs. They were pretty much do everything. Email, chat rooms, file store, what have you. Well, spin forward, they're still popular, but they're web-based. And here's one here. It's called Citadel. Again, this runs nicely on a Raspberry Pi. Has everything you'd want: calendar, mail, contacts, notes, tasks, chat rooms. We tried this. It works very well. If you had a group that did a lot of communication via mesh on a project or something, you might want to set up something like this where they can share files, chat with each other privately, whatever. We tried it. It works fine. So RoIP is repeater over IP linking. I've listed 3 commercial companies up there. They range from expensive to really expensive. You can get the units on eBay, quite less expensive. And you can see that they need Ethernet linking between them. It could be wired, or it could be the internet, or in our case, a mesh network. All the signals you need for linking 2 repeaters together are there. Now notice that's point to point. I'm told somebody has ported the protocol to a Raspberry Pi, and if you sit a Raspberry Pi on each of your repeater sites, that you can link them together via mesh and do all sorts of sophisticated linking, repeater A to B, C to D, all of them linked together, but 2 of them in listen only. Sky's the limit, and I'm told it has a good web interface. I've not seen it yet, but lots of potential there. That would be a real impetus for pushing mesh between 2 sites if you wanted to link them together, because linking repeaters are just as expensive as regular repeaters. I'm told for new equipment, each end would be between $500 and $700. Well, for $1,000, you could buy a lot of Raspberry Pis and mesh equipment and link the 2 sites together. That would be a reason for putting up mesh in the first place. Something else you can hang on your mesh network is a weather station. This is mine. It's running open source software called WeWX. It's easy to install, runs on pretty much every operating system, and supports pretty much every weather station known to man. We have at least 2 and 1 more coming online in our county. So, excuse me. This is the 2 gigahertz band. Before we had the capability of moving down into the Part 97 channels, we all use channel 1 here locally, 10 megahertz bandwidth. And like I mentioned previously, you're sharing it with everybody and their grandmother's access points. So the signal noise ratios were not that great. In October of 2015, I think, AREDN published beta code, that allowed us to move down out of the band. So we all moved down to channel -2 at 10 megahertz bandwidth. And the improvement in performance was astonishing. I mentioned that 3.5 mile link here in town. It went from about 75% LQ when we both moved. When we both moved, it went to 100% LQ both directions. Link quality is LQ. The reason we don't use channel -1 is because there are a lot of really poorly designed wireless access points on 2 gigahertz, and a lot of them spill way over the band. They shouldn't, but they do. So we use 0 and 1 as a guard band. Now, if you're out in the boonies and you're linking 2 hilltops together and there isn't a town for miles, you could probably easily get away with running on channel -1, and you could run 20 megahertz bandwidth. You can't run 20 megahertz bandwidth on channel -2 because the bottom of your signal will be out of the band low. So, I'm going to talk about 5 gigahertz down on the bottom first. Lots of channels there and lots of opportunity. And in a dense environment like LA County, lots of Wi-Fi in there. A lot of the hams do use not just the ham band, but not just the strictly Part 97 part, but the blue channels also. You can get away with it because typically you're linking hilltops together on 5 gigahertz, and you use dishes or beam antennas. to focus it. It is still a problem because the RF density on some of these hilltops is just incredible. And the other thing is, I set up a 5 gigahertz user access point down on channel, I think 182. Next day, I got an annoyed email from an ATVer. It seemed I was parked on the input of an ATV repeater. They're very popular in Southern California, so I had to move to 177, and it works fine. The ATVers are starting to talk about linking their sites together via mesh too. So their analog 6 megahertz wide analog channels starting to look pretty inefficient, considering only one person can use them at a time. I think they'll be going digital before too long. So the 3 gigahertz band, you'll notice there's no blue. There is no Part 15 allocation on 3 gigahertz in the United States. That's both good and bad. The good thing is it's all ours. The bad thing is it's hard to get equipment for it. What you have to buy is the export version of the equipment, and you have to find a vendor who's willing to sell it to you stateside. Some of them are very lax about it. They don't care. Some of them require a copy of your license and will only ship to your callbook address. But it works very well. The equipment is more expensive. It's about double the cost of the 5 gigahertz, so I wouldn't recommend it for home, but we do use it for some mountaintop linking. So for use in the rooms there, looking at this is a bit of an eye chart, but that's okay. This is the one screen of the AREDN node interface. It's just a web interface. And everything there you see underlined is just a URL to take you someplace else. There's 2 columns. On the left-hand side is the local hosts and remote nodes. On the right-hand side is the current neighbors. This is a zoom in on the current neighbors. This column, the right-hand side of that screen, shows the RF neighbors and the networked neighbors. On top, you see LQ, NLQ, TX, MBPS, and services. Link quality is how good you're hearing the remote site. NLQ is neighbor link quality, how good they're hearing you. This is the 5 gigahertz nanostation up on Chatsworth Peak that I showed the photo of. These are the stations it's hearing. You'll notice they're almost all 100%. The TX Mbps is what I talked about, the modulation rate, and tweaked slightly, but it's very easy to get 100% LQ and NLQ. You ought to strive for that and then pay attention to the TX Mbps. That will tell you really how much traffic you can pass. And again, this is just point to point. After 3 or 4 hops, it's a fraction of that speed, but since we started out so fast, we're in good shape. Our backbone, our county backbone from end to end will pass about 7 megabits per second. A lot better than 1200 baud. On the services on the right, there's GNB's backyard cam and YXY, various services, and some of those are websites, some are not. I want to talk about the 3 at the bottom, which are not RF links, but they are neighbors. If you guys remember way back in the packet days, it was all point-to-point or digipeaters, God forbid. But then NetROM came along, which allowed you to do routing. Additionally, it would let you hook 2 TNCs back-to-back via their serial ports to cross over from, say, 2 meters to 220 and do backboning and routing like that. And they would broadcast routes out that serial port. Well, these 3 at the bottom are doing the same thing. DTD means device-to-device link. And it's just a broadcast out their Ethernet port. If you have 2 of them connected together at a site via Ethernet, they will route accordingly. It's very slick. So that's the right-hand side of the interface, the user interface. Here's the left-hand side. These are remote nodes. Just like you have packet stations that are multiple hops away, you can have mesh nodes that are multiple hops away. The ETX is expected transmission count. That's sort of the number of packets you have to send to get one through. And I chopped off the bottom of this, and those ETXs go up to ridiculously large numbers, and you have no hope of passing audio, much less video on them. You really want to keep these hops. If you want to use video, keep the ETX count below about 4, I'd say. So anyway, these are things that are out remote from us, not directly connected. All sorts of services, whatever you want to put up. So, again, this is Southern California centric. My apologies, but it's a good example. If your node has internet access, you can register it on the AREDN website on their map. The colors indicate various bands, but since you have to have internet access, this is probably really drastically under-reporting what's out here in Southern California. I would expect as little as a third. Here's a better way to do it, in my opinion. KG6WXC wrote some code to go out and actually poll the nodes. There's all sorts of information available on the nodes, and he maps them, shows link quality between them, and of course the frequency and stuff. If you click on the live map, if you click on a node, you get something like this. All the information about where it is. You'll notice if you have your latitude and longitude shown, he can place it on the map, and he will show the bearing and distance to the nearest node, to every node it can talk to. So that's pretty cool. And recently, he's made the code available via a GitHub instance he's got going. And he's encouraging people who are comfortable with Linux and run mesh to download it and run it. He'd appreciate feedback. It's not beta code at this point. It's fairly stable, but he's always looking for fixes and suggestions. He's on the AREDN forums, and you can contact him there. So where do you get information? From AREDN.org. On that site, they have all the software downloads, some how-tos, FAQs, documentation, forums, and by the way, there are regional forums. And if you don't find one for your site and you want to have one there, ask Randy WU2S, the web admin, to create one. He'd be more than happy to do it for you. There's also a Facebook AREDN page. It's not for support, just for chit-chat and photos and stuff like that. You can log in there. And again, these two here are local. I noticed I wrote down MiamiValleyMesh.org, and I'm sure there's many more. OCMesh.org is run by KE6BXT. They were into mesh very early, and he's done a very good job of documenting hardware links and stuff like that. Tends to be a little Orange County oriented, but still some useful information. Mine, pvark.club/mesh, is where I maintain stuff for Ventura County. There's some how-tos and how to get started and recommendations and site-specific info too. I'm sure your area has one too. If not, start one. So what can you get? The current production code is about 2 years old for various reasons, but it still supports those 4 bands, two brands of equipment, the older Ubiquiti and older TP-Link, the 4 bands we talked about. I didn't mention this before, but if you have internet access on your node, you can tunnel to another node that has internet access and at least get on their mesh network. If you put up a node and you have no RF links, but you want to get going, ask somebody in the AREDN forums if they'll let you tunnel to them. It's a good way to get started. And bridging gaps on an interim basis until you have real RF links. This is the big thing that allowed it to take off. Having these nodes be able to move out of the part 15 part of our bands really lit a fire under mesh activity everywhere. This stuff works so much better when there's only 4 of you on the channel instead of the 25 I saw when I was in channel 1. And I mentioned 802.11n. What that does is a data stream goes out vertically and horizontally and is decoded vertically and horizontally at the other end. So if you're running an old style bullet that's not MIMO, for the same signal to noise ratio, same link quality, by swapping out for MIMO on both ends, you can double your throughput pretty much. We're not recommending anybody use bullets or anything that isn't MIMO anymore. Other current software is the nightly builds. The build software runs nightly. If there's nothing new to build, it won't generate anything new. But it's current. They've added all the new stuff, support for all the new hardware, fixed some bugs. It is a little easier to install on newer equipment. It used to be you had to down rev the AirOS first and then upload the Ubiquiti stuff. They've eliminated that. You can get it plus instructions at AREDN.org. Excuse me. So, you want to get started with mesh networking? Ask around your club, ask around the repeaters, see if anybody else is messing around with it. I gave a presentation, where was that? Somewhere in South LA County to a club. There were 35 or 40 people in attendance. Presentation went well, and afterwards some guys came up and chatted with me. It turns out 3 of them in the same club were on mesh but didn't know each other were. I sent them off in a corner, and when I left, they were talking intently about how to improve their linking between each other. So talk about it. If there aren't any local meshers, buy 2 nodes. Give one to a nearby ham friend or stick it on your non-ham neighbor's roof. Excuse me. You may have to cut a few branches to get it working. Or alternatively, you can tunnel between them. Again, that'll require an additional purchase of that VLAN-aware network switch. Throw up a service or 2. If you're comfortable with Linux, get a Raspberry Pi. It doesn't even have to be a Raspberry Pi. It could be your mesh computer, whatever. Or if it's a Windows computer, there's web software for Windows computers. I prefer running all the services on a dedicated server so I can reboot my shack computer when I need to and not interrupt services like the like the weather station runs on a Raspberry Pi and it sits under the desk and I never look at it. You really need a high-level site that multiple people can get to. Make friends with repeater owners. Get your repeater owners hooked on mesh. That makes it much easier. The stuff doesn't take a ton of tower space, and there's very little that goes in the repeater building. Maybe a network switch and maybe some battery backups, but if they already have battery backup, you can hang off of that and buy them an extra battery. Join the AREDN forums, read, get yourself an account there, because if you're logged in, if you sign in, it will tell you what new postings have been made since the last time you looked. Typically, I see 4 or 5 a day, and it's always nice to keep up on the reading. If you have questions, my call sign at ARRL.net works, or you can Google it. AREDN makes great reading. I was looking for other sites out there that had information on mesh networking, and a lot of them have not been updated since the Linksys days. I wish they'd take that stuff down because, to my knowledge, very few people who are active in mesh are still using the Linksys equipment, and the information on them is pretty much irrelevant anymore. That's the end of the presentation. I can take questions, or we can go to lunch. Oh, that's right. You guys already went to lunch.
No 7. Could not figure out.
Oh, we're unmuted.
That's okay. I heard you.
So what do you want to tell me?
What do you want to know? Any questions out there?
16.1.1. The routing works.
You forgot the period in 3.16.1.1.
My bad.
Yes, we are.
Oh,
That's okay. I don't mind. But my point is, use the nightly builds.
This was for the guys in Licking County. Let them ask the question. I'm sorry, what was that question? I said this was mainly for the guys over in Newark, right? So we'll let them ask all the questions.
Let's see. We have a question here from David, N5 MXI. Wants to know what's the best source for the apps being discussed. Well, I'm pretty much all Linux based. That'll be a limited answer, but basically Google. WeWX is the weather software. It's at wewx.org, I think. But again, Google it. TeamTalk is just Google TeamTalk install, TeamTalk client install, and it'll take you to, I think it's Bearware is the company that supports that.
Bearware.dk.
Right, thank you. What other applications? Oh, IRC. IRC servers are available for Windows or Linux, and clients are available for Windows or Linux too. Somebody asked about MeshChat 1.0. I'm not sure what version MeshChat is at now. We stopped using it about 0.7. You can ask in the forums, and I'm sure Trevor will point you to his repository. It's up on AWS someplace, Amazon Web Services.
It's on his website. It's been 1.0 now for quite some time.
Good deal. Do you guys use it?
Yes. We have three instances of it, and they link together, so you can connect to whichever 2 gig node is near you to get on MeshChat, and everybody in the whole can share.
Right. Do you run them on Raspberry Pis or still run them on the nodes?
One is on the node, 2 are on Pis.
Excellent. Excellent. Yeah, they found with the really busy nodes running MeshChat that they would run out of memory and reboot. Yep.
We'll have to tell Ruben that.
Well, if his isn't rebooting, then it's not a big deal, but eventually he's going to have to do that.
Yeah, I ran postfix and squirrel mail on one Raspberry Pi, but we had a complete email system, but nobody used it, so I took it down. We use TeamTalk here quite a bit. Right now, we're using it mostly over the internet, but we're really fascinated with it right now. MeshChat's there for bad conditions, but
our current TeamTalk server is at a ham's house who has a good link into the system, which is a great idea. But if he loses power, we're off the air. So what I'm planning on doing is moving the TeamTalk server up to the mountaintop site where the mesh is and hanging it right off of the backbone. That way we, A, it has battery backup, and B, has an even better connection to everybody else outside the valley.
Our TeamTalk server is dual ported on the mesh and the internet, so somebody on the internet can talk to somebody on the mesh.
Nice. Does it have battery backup?
Yes, as of this week it does.
Oh, excellent. Excellent.
And it's solar too.
Nice. I may have to do that.
what else?
Any other questions or discussion?
Got the mesh map running.
Yeah, Chuck has the mesh map running on one of his nodes.
Good. Which mesh mapping software is it?
The KG6 WXC.
Oh, Eric will be thrilled to hear that.
He's already sent him an email, and he replied right away. He's a big help.
He is. He's a good dude. He's let me put it this way. He's not bothered by full-time work, so he's pretty much full-time mesh development.
Work? What's work?
Yeah, I wish I could say that.
In this room.
David said he wants to know where he can get some mountains because it's pretty flat in South Texas.
Hey, I feel your pain. My boss is.
We're going to send you a picture of our hilltop. And you're not going to see anything but trees.
That's the other problem.
Our tallest hill is 200 feet, and we have 80-foot trees.
Yeah, we're kind of spoiled here in Southern California. Lots of hills with not a lot of trees.
But by the way, we are running some 900 megahertz nodes. So,
Good.
Michael, anything from the Newark group? Questions, comments?
Not so far. We're just getting our feet wet in this whole process. We've had a couple of other members of our group attend presentations on mesh networking, but so far we're still not quite to the point of getting a couple units and getting a system running. So we're very early stages of thinking this.
Well, everybody's got to start sometime. Hopefully this information will help you get going a little more expeditiously.
There are a couple counties in Ohio where they have a fairly well-established mesh networking system. I know Delaware County and Franklin County both, and they're very close to us. Which one? Oh, Knox County. So we're surrounded almost.
Well, once you get a few nodes going, linked together, tunnel one of them over to one of those islands and get linked together that way in the meantime.
And of course, us guys in Dayton have a big one too.
We're in Montgomery County. There's a county in between us, but we don't see anything on the AREDN map for Delaware and Franklin County.
Oh, that's interesting.
Well, post something in the AREDN forums relative to that geographical area and ask if there's any activity. You might get a response.
Okay.
Yeah, the AREDN maps are very incomplete. We've talked about possibly rolling the data that AREC KG6WXC's mapping software covers, rolling it into the AREDN map, but that's a future task. Oh, by the way, while I'm talking about that mesh mapping software, I'm pinging Eric, and he's thinking about creating a master database where every mesh mapping software can import their data into it and showing all of the mapping stuff on one map. I'm still pushing him on that. He hasn't quite committed to it yet.
There's a problem with it, though, that they cannot distinguish between a 900 and a 2.4. MeshMap sees all the 900s as 2.4s.
Tell him that. We don't have anything for him to test.
Okay.
And Mark N2MH has his map covers just about the whole world.
Yes.
Yeah. No, he's the linking king.
Well, we'd like to hear from our neighbors over in Delaware, Franklin, and Licking County.
Yes.
Get on the forum. Start beating on them.
All right.
If they don't mind driving a couple hours, we have a meeting first Saturday of every month over here.
Second
Saturday, I'm sorry.
Maybe find a meeting site someplace in between. Okay, guys, if there are no more questions, I think we can wrap it up.
One more question. Where is GEL-MCE located? Oh,
Dayton, Ohio.
Okay. This is WACI, the Dayton Amateur Radio Association. All right, great.
It's my computer, but it's their site.
Home of Hamvention.
And we're glad to have you here. Okay, John.
There was a big presentation there. Yeah, thank you very much for the presentation, Orv. Really appreciate it.
Oh, you're very welcome. Happy to do it. And if you want me to reprise it for any other group, I have my own Zoom private account, or we might twist John's arm to do it again.
Okay. And also, thanks to John Kennedy for setting this up for us and running the Zoom conferencing software. Thanks, John.
More than welcome. And thank all of you for joining. If you didn't get logged in, and you can kind of do it real quick before you sign out so we know where you're from, we'd appreciate that. Or thank you so much. And or we'll let everybody know if this video gets uploaded to the internet and accessible for other people to watch. So thank you so much. And when you're done, you can click the button that says Leave Meeting. I'm going to wait just a bit. I heard some clicking that somebody might be, trying to type something in. And oh yeah, Orange, California, Orange County. All right, thanks so much. Have a great day wherever you are, or go have a good lunch. The rest of us will have a late lunch or an early dinner.
Thanks, guys. Appreciate the opportunity. Go out there and mesh. We'll see ya.